Well, hello everyone, and welcome to this webinar on source code protection in hybrid mobile apps. As the name implies, we will be going through the state of mobile app security with special emphasis on hybrid mobile apps and what can be done to improve their security. I want to start by letting you know that this webinar has been pre-recorded, so if you have any questions, you can reach out to us at hello@jscrambler.com and we will gladly answer them. Let me then begin, of course, by welcoming our speakers for today. Joining us, we have Pedro Fortuna, who is the CTO and co-founder of JScrambler, and Neil Michi, who is the Director of Product Management at Verimatrix. And we will get things rolling precisely with Neil, who will introduce the topic of mobile apps and their value to companies today. Thanks, Neil, and feel free to take it away.
First of all, thank you to Pedro and the excellent JScrambler team for inviting me to speak today. And of course, thank you to you for taking the time to tune in as we dive into the concept of every company becoming an app company and the security considerations that brings. I'm Neil Meeke, a product director at Verimatrix. You may not have heard of Verimatrix, but you've almost certainly been protected by us, as we work with some of the biggest names in finance and media, specialising in protecting applications and content as they're sent out into the wild. A good example of that is a mobile application being installed on your customers' phones. Over the course of the next 15 minutes or so, I'll explain what we mean by every company is an app company, why that's the case, and then look into the security risks that brings. We will then talk about the rise of hybrid apps. If you've been to a conference or watched the occasional webinar over the last few years, you've almost certainly heard the phrase, every company is an app company, and seen a slide much like this one. The slide is interesting, not because of the statements on it, but because of the detail behind it. If we take the hotel example, we can make the same statement about Marriott, Hilton, Best Western, pick a hotel brand of your choice. But long ago, the hotel industry realised the benefits of the franchise model. For the brand, it gives reach while allowing them to push the investment risk out to their franchisees. For a franchisee, it drives business through a trusted name above the door. Did you know that a hotel franchisee pays the brand higher fees if the guest is a member of the hotel's loyalty program? And for the guest, it gives consistency, which builds trust and loyalty. And it gives convenience through a common portal to book and manage stays. The gig economy, these apps that we see, have taken franchising to the next level, almost franchising 2.0. The two C's of consistency and convenience are key to the success of any service on mobile. Why do we take 100 times the number of pictures with our camera phone versus our old digital cameras? Because it's easy to. The trendy app companies have made it easy to consume their services. And as much as possible, they've made the experience uniform, wherever you are in the world, however you're using the app. Why do we hop in an Uber when we land in a new country rather than go to the taxi rank? Because the app is already installed. There's no need to find local currency or worry about if the taxi will take card. And you know exactly the service you'll receive. It's easy, it's consistent, it's convenient. This is the new reality, and this is what customers expect from all companies. The only way to compete is to make an engaging mobile app your primary interaction point. Of course, building a mobile app as a defensive play is the wrong approach. It's those companies that fully embrace mobile that succeed when competing against the tech startups. For reasons that have been well documented, remote engagement with services has increased greatly in the past year. For example, mobile banking usage has doubled in the US. Switching across the Atlantic to the UK, did you know that 19% of citizens log on to their mobile banking app every day, and just under half do it at least once a week? That's a pattern we see around the globe. It creates a regular, ongoing conversation with customers that just wasn't possible in the pre-mobile, pre-digital age. The strength of mobile and web is the conversation that can be built and increased and personalized for the individual consumer, individual customer. Who'd have thought we'd get a more personal experience through a screen than in person? But that's exactly what's happening. That's the power of mobile. Of course, wherever you do business, you need customers to trust their interaction point. You wouldn't bank at a branch with boarded up windows, graffiti on the doors, half the lights smashed in, and the staff dishevelled in scruffy t-shirts. No, you'd expect the branch and the staff to look professional. The same is true of any business. The image it presents needs to reflect the values of the brand. That's how trust is built. Trust and security are often confused. While they are linked, they are not the same thing. Trust is an emotional attachment. We need to trust the companies we interact with. Security is an implementation to keep things safe, a technical solution. The interlinking comes when security is compromised. It breaks down the hard-earned trust. So what's all this got to do with mobile apps? Well, when you publish your app, you send it out into the wild. The challenge is your app is also part of your infrastructure. It contains valuable customer data. It doesn't run in isolation. It works in conjunction with your backend infrastructure. Leaving your mobile app unprotected is the software equivalent of not locking the door at night of your high street branch. What does that mean in practice? Attacking an app or the ecosystem it operates always starts by understanding the target and finding vulnerabilities. It's called reverse engineering. Think of it as staking out the bank before robbing it. Now, there's a misconception that an app installed onto a phone is locked away and can't be touched. The reality couldn't be further from the truth. It's easy to lift an app off a phone and start to analyze it. The Android development environment even provides the tools to do it. With access to the app, even a moderately skilled hacker can quickly find interesting assets and code within it. These assets include information like how the app talks to backend systems. With this information, an attacker can start to abuse APIs. We also find how personal data is stored and processed, thus allowing an attacker to craft malware to siphon off the data. And we find vulnerabilities that can be remotely exploited, allowing an attack to quickly scale. The technical risk quickly becomes a real business one with regulatory, for example, GDPR, impacts. A lot of developers put their trust in OS sandboxes. These are designed to keep your application isolated, stop hackers and other apps from spying on it and manipulating your app. This is the dynamic analysis shown on the slide. As mentioned, it's easy to lift the apps off the phone, but the reality is trust in sandboxes is misplaced. For example, Verimatrix data shows that 36 out of every 1,000 Android devices is rooted. That means a large portion of your customer base has chosen to remove the sandboxes from their phone. This increases your risk. This is before we take into account that 19% of active devices are running an outdated operating system. That means there are lots of known vulnerabilities for the bad guys to exploit. Verimatrix has researched the app security of a couple of very security conscious industries. In conjunction with UL, we found that 95% of banking apps weren't taking appropriate security measures. And when looking at the video streaming and a class of apps known as OTT, we find a similar story. In both cases, when we dug deeper into the high-level figures, we found an over-reliance on traditional security measures. This isn't naivety. On the contrary, there are a lot of very bright people working in security at these organizations. The reality is simply that mobile app security falls into a gap. Traditional risk and security teams are focused on back-end security, while the mobile development teams often believe security is taken care of elsewhere in their organizations. Where companies get it right is when they empower their mobile development and product teams, giving them time to understand the challenges and giving them space in the development program to build solutions. With even the FBI warning hackers are targeting mobile apps, this is a trend that has to accelerate. Oh, and if you want the details of that research, the papers are available on the Verimatrix website to download. So I said at the start I'd introduce something called hybrid apps. These are mobile apps that use web technology like HTML and JavaScript to implement some or all of their business logic. Hybrid apps are nothing new. Developers have been using frameworks like Apache PhoneGap for many years. But what's changed recently is these frameworks have matured rapidly. Back when I was working in engineering, about 5 years ago, I hated developing hybrid apps. The end result was always clunky and didn't integrate nicely with the rest of the phone environment. Now, with this rapid maturity, the end user can't tell the difference between a hybrid app and a native app. It's a smooth, slick experience. From a developer point of view, the advantage of hybrid apps is simple. You write your code once, and it runs on every platform you want to target. Android, iOS. The same code runs. From a security perspective, though, the story isn't as clear-cut, at which point I'll hand over to Pedro to explain. Thank you.
Thanks, Neil. Hi, everyone. Before I get started, just a few words about my background. So I've been working in security for more than 15 years. The last 10, I have decided to focus on application security, code protection, and client-side security in general. Neil already gave an excellent overview of the importance of mobile security, and so I'll keep us going by exploring his last topic a bit further. Hybrid mobile apps are really interesting because how quickly they are growing, and these hybrid apps are actually a result of how JavaScript evolved through the years. Today, pretty much everything on the web is powered by JavaScript, and as JavaScript development ecosystem grew over the past years, we saw some cross-platform frameworks grow in popularity. Frameworks like React Native, Ionic, and NativeScript are today used by thousands of companies around the world. Not just to build basic mobile apps, but also to build complex ones for banking, healthcare, streaming, you name it. But if we are a company building this type of critical apps that are powered by JavaScript, we need to understand the changes to threat models that can be caused by using JavaScript. So one particular important aspect is that client-side JavaScript can easily be targeted, which means that anyone can debug our code and in some cases even modify it at runtime. So in the case of hybrid mobile apps, the application packages will typically contain a JavaScript bundle file with the logic of our application. And the source code of these apps is stored in the end user's device, putting it more at risk. So still, this wouldn't be a problem if we were talking about the standard code that could be publicly accessible. Well, if you are familiar with 101 of application security, you know that code secrets should always be kept on trusted execution environments like the backend server. But in reality, companies frequently place proprietary algorithms on the client side. And some of the reasons are because there's not a backend in the first place, as in the case of offline mobile apps. Some code that is related to the user experience, like analytics algorithm that needs to run on the client side, and and for performance reasons, centralizing computations on the server when you have thousands of even millions of users can be overwhelming. So application developers often prefer to move some of this computation to the end user's computer and borrow their CPUs. Also, because of server calls take time, and when you have a service where latency is crucial, paying the round trip time is not an option, or is, at least it's costly. Whatever the case, companies don't want to expose their proprietary logic, especially when their competitors can reverse engineer the code and copy or tamper with the proprietary algorithms. And this can lead to more advanced attacks like automated abuse, piracy, cheating, or even data exfiltration. So, how can we prevent this? Well, if we take a look at some of the most common security standards and frameworks, we start to find some answers. The ISO 27001 standard, for instance, has a section that is dedicated to access control, where they state that we should find ways to restrict access to the application source code. Otherwise, this may help attackers find ways to attack the system. Another important standard to consider is the Secure Software Development Framework white paper from NIST, which also states that we must make it harder for attackers to modify the code, namely by installing integrity checks in it. We can also take a look at what the security community is recommending, looking, for instance, at the OWASP content. Specifically the top 10 mobile security risks, where it's outlined the risk of code tampering, stating that the app itself must detect and react to any type of code integrity violation at runtime. OWASP also mentions the risk of reverse engineering, and their recommendation is very straightforward. If we want to prevent reverse engineering, we must use an obfuscation tool. And for high risk applications, that should be mandatory. But let me stop here because I sometimes get this question. Basically, an application owner might say, hey, I already use SAST or DAST to find vulnerabilities and to fix them. Doesn't this solve all my code problems? Well, it solves some problems, but certainly not all. It doesn't prevent code tampering and reverse engineering, as vulnerabilities are not required in order for the attacker to do that. So of course you should look for vulnerabilities using SAST and DAST, but alongside use source code protection. So the best option is to protect mobile source code so that it becomes extremely hard to understand, while also adding environmental checks, anti-tampering, and anti-debugging capabilities, which are all runtime defenses. To protect the source code, we start by using obfuscation. This is the foundational layer of any code protection. So obfuscation is usually a combination of multiple source code transformations so that it becomes unintelligible but semantically equivalent to the original code. In this animation here, you can see a before and after a piece of JavaScript code that has been obfuscated. In this case, the protected code doesn't even look like recognizable JavaScript. But this is just a starting point. So when you're dealing with advanced attacks like piracy, abuse, and data exfiltration, we must also consider other types of defenses built on top. One such defense is environmental checks. Their main purpose is to lock the code execution to trusted environments only. Here we have some examples of types of checks we do on the web and on mobile apps. But one that is especially important in mobile apps is root and jailbreak detection. If you have an app that deals with very sensitive data or performs critical tasks, it's generally a good idea to prevent it from running on devices that are more susceptible to attacks like rooted or jailbroken devices. Another important defense is self-defending. In scenarios that we have attackers that are highly motivated, they may try to reverse engineer the code logic by debugging the codes and by tampering with the codes at runtime. So to counter this, we can install integrity checks throughout the original code together with anti-debugging mechanisms. This will allow us to detect tampering to the code and to detect when someone is engaging in debugging activities, which will trigger automated reactions from the code to mitigate the attack. We call these automated reactions countermeasures. The application owner can choose multiple options. So in some cases, one may just want to derail the application execution to stop the attack. But in others, we might want also to frustrate the attackers by, for instance, redirecting them to a different URL or clearing the session cookies or forcing them to restart the debugging from scratch. Eventually, it gets to a point where they are more likely to move to different targets out of frustration. Finally, besides making sure that we add enough defenses, we must also protect all of the source code that is susceptible to tampering and reverse engineering. In the case of hybrid mobile apps, this means we must protect JavaScript code along with native code and platform-specific code like Java or Swift. I actually have a demo to show you that we can quickly see an example attack and how we can get protection against it. Here's a very simple groceries mobile app. It follows a freemium model. So free users can have up to 2 lists, and premium users can have as many lists as they want. Now, let's say I'm an attacker who wants to unlock the premium account without paying, because 2 lists are not enough for my highly sophisticated grocery needs. By getting my hands on the application package, I can quickly extract the source code of the app. Typically, I look for a JavaScript bundle, like the one we see here. And the next step is to look for some way to forcefully upgrade my plan to premium. Depending on how the code is structured, it can take more or less time to find it. In this case, it's rather easy to find it. I can now modify the code to change my plan to premium instead of free. At this stage, I can easily build a template version of the APK file with a modified JavaScript code and install it on my device. Now, when I run the modified app, right off the bat, you can already notice that some things look different. The app is now displaying as the premium version instead of the free version. But to be sure, let me check if I have permission to create more than 3 lists. Okay, it worked. I have 3 grocery lists, so the attack was successful and I can go crazy and create grocery lists for the whole neighborhood. So well, While this scenario is entirely possible, my attack mostly depends on my ability to understand and modify the original source code. So now we may ask what would happen if this app had been protected. So if I conceal the logic of the source code, added environmental checks, self-defensive capabilities, would my attack still succeed? So to answer this question, let's look at how we actually protect the source code of our app, and after that I'll redo the attack. Since this is a hybrid app, it contains native code and JavaScript code. So I should first protect its JavaScript source code with JScrambler. This will add the JavaScript obfuscation and runtime protections, and the JavaScript files in my APK or IPA files are all protected. But now we still need to address the native code and platform-specific code. This is where Verimatrix comes in with their code protection tool and APK Defender. They obfuscate the native code and add integrity checks and other security features to improve my application defenses. So I won't really go into much detail about how these products work, but feel free to bring up your questions during the Q&A at the end, and I'm sure that Neil and I will be able to help. For now, let me show how the attack would unfold if I had protected my app source code. So like before, I opened the JavaScript bundle file, which contains the logic of the application. And as you can already see, it looks completely different. This is protected code that not only is obfuscated, but also has anti-tampering and anti-debugging defenses. So let's search for the string premium, and I will get no results as all the functions, variables, and strings names have been concealed, and I cannot find these strings and identify any logic. So even though I can't understand the code, as an attacker, I would still try to follow some leads. And based on the looks of this code, it seems that this code is either encoded or encrypted. So I can see that there are a few eval function calls in the code. So I would assume that whatever it's being passed to this function call, it's probably the decoded or decrypted code. So I can try to output the contents of those parameters. So let me save this new tempered version and I'll run it on my device. Okay, the application is opening up. And there we have it. It's not running at all. What happened is that the integrity checks picked up the modification. So even though it was a small modification, it was enough to trigger the countermeasures, which in this case was to derail the code execution on purpose to mitigate the attack. And this is just the tip of the iceberg. If the attackers wanted to use reverse engineering tools or go through the native code of the app, they would face similar security measures, which would frustrate their intents. As all of these failures pile up, it gets to a point where they're more likely to quit and to move to the next target, which will probably be easier. So this basic demo was just to give you an overall idea. Of course, there are many other intricate attacks, but I won't be going into those today. So, final thoughts. Today, we went through the current state of mobile apps and mobile app security. Now, more than ever, we have companies that are built around their mobile apps. And these apps require very strict security to prevent attacks. Several of these enterprise apps are now being developed with hybrid frameworks, which means that a significant portion of their logic is now written in JavaScript. This code can be targeted, not only the JavaScript, but also the native and platform-specific code. So to counter this, we must use obfuscation alongside environmental checks and runtime defense capabilities. And this is precisely what JScrambler and Verimatrix offer, an integrated solution that protects the whole source code with enterprise-grade code protection. And well, this is all from my side. Thank you.
Thank you, Pedro and Neil, for this excellent presentation. I want to remind everyone that you'll receive an email with our one-pager on enterprise code protection for mobile apps, which gives an overview of what we discussed here today. As I've mentioned earlier, if you have any specific questions, feel free to reach out to us using any of the emails you see here. Well, and that's it from me. Thanks, Neil, again. Thanks, Pedro, for both your input. And thanks, of course, to everyone out there joining us today. See you next time, and don't forget to protect your mobile apps.